Hello and welcome back to Calculus 1, section 5.5 on u-Subtitution. So we're going to start by clearly stating that u-Subtitution is backwards chain rule. So u-sub is backwards chain rule. Now we know that chain rule is the most used the differentiation technique. Most of your derivatives you ever take are chain rule. Therefore, it should be natural that the opposite integration technique, the one that undoes the chain rule, is the one that is most used as the integrals. And you will see this one in all of your calculus courses, including your differential equation course and beyond whenever calculus integration is used. Now, what is happening here? Well, if you have the integral, say, of x plus 9 squared dx, you have an option to just square this, right? Get your x squared plus 18x plus 81 and integrate. You get the plus c at the end and you're done. And yeah, it's easy because it's squared. But what if this is 29? You're going to FOIL it now? I'll be back on Thursday. All right. So the idea here is to try and figure out how to integrate this without foiling the 29th power up there. And the answer is, you just say, it involves a little bit of attitude, right? You just go, if this stuff over here was just like one variable, then that would not be an issue for me to integrate, right? If the whole thing was like x, like this, then I would just have x to 29, and then we know it's just x to the 30 over 30, and we're done, right? Easy peasy. So this is what we are trying to achieve. We are trying to change the problem in a way that we are going to be left with a basic integral, you know, the ones you learned and memorized in 4.9. So this is where your substitution that you have to figure out, you have to come up with, comes from. And that is u equals x plus 9. So you are the one who replaces this mess with a u to make this into u to the 29, because u to the 29 can be easily integrated into u to the 30 over 30, and we're good to go. So the now issue which we created is that you have your problem as u to the 29, but you still have dx, and that's not good. You can't have an integral in terms of u and in terms of x at the same time. So you have to change the dx part into du as well, and you achieve that by differentiating your u-Subtitution that you came up with. So now when I differentiate this, I get du dx is equal to 1, from where du is equal to dx, and now I can sub everything in. Instead of x plus 9, I will write u, and then I still have a 29th power up there, and instead of dx, I have du. So I use the substitution to replace all of the expressions which contain x's into this new integral that only contains u's. So now we will integrate. We will get u to the 30 over 30 plus c. It's a plus c or minus 1. You pick.
Where did the 1 come from? Where did du over dx equals 1?
The derivative of x is 1. The derivative of 9 is 0.
Okay.
We are using just a regular derivative. All right? You don't have now y over there. You have u. So, but it's the same derivative. Okay. Are we done? No. The problem was posed in x, but the answer over there is in u. So we have to now switch it back and, right, go back. So it's very easy to remember that. You just say, I don't care about u, I care about the x. And just be careful. Yeah, because the problem was posed in x's, right? Okay, good.
Yeah.
So,
I only care about my x too.
so again, the problem was, yes. So we have 1 over 30. Instead of u, I have to put x plus 9 raised to the 30th power plus c, and this is the answer, right? That's the answer to the question. You see that the problem was posed with x, the solution has x, we're done, right? The process in between, we swapped to a domain of u so that we can solve the problem easier.
Where does that 1 over 30 come from?
That's u over 30, I just kicked it out, right in front. Yes. I split the fraction. 3/2 is equal to 3 times 1/2. That's exactly what I did, except now I have functions. So, gee, I know. It's just, I mentioned algebra, everyone loses their minds. No one has issues with calculus. I mean, let's take a look at another one of these examples. Let's say that you have integral of something familiar, e to the 6x dx. You already know the answer to this because many of you answered this already on a previous exam, right? You know that you are just supposed to say, oh, e to the 6x divided by 6 plus c, and you're done, right? Now, you know, every good 5-year-old would say, why? So, let's go. The first thing we do over here is the attitude. You would just say, oh, if this was just e to the x, right, then it will be easy because integral of e to the x is just e to the x and move along, right? So you always have this battle if what you have and what you would like to have. And that is where you figure out what the substitution is, right? So clearly in this case, u equals 6x because I would like to remove that exponent and put a single unit u there because it creates a very easy substitution. Now, what this brings now is the derivative du dx is equal to 6, and then du is equal to 6 dx when you move dx to the other side. Are we all okay with the blue stuff? 100%. Blue stuff.
I am not.
Let's go. U equals 6x. Why do I have u equals 6x? Because in the problem, I would just like to have u e to the one variable. So I'm replacing that mess of 6x with a single variable, and that's where we get our substitution. Once I have that, I'm going to differentiate this, and differentiating both sides in respect to x. Derivative of u in respect to x is du dx. Derivative of 6x is just 6. And then this is a fraction. Move dx to the other side. We learned this when we did differentials. We used to move dx to the other side to get the differential formula in 4-point block. So we have this procedure, and this is going to be standard procedure in every problem. You will have to have the blue, right, where you go and you create this u sub. So now I have everything that I need to plug in over there, except, do you see how I have a 6 dx here? And I don't have 6 dx there. I just have dx. So from this point on, you can do one of the two things. you can either fix the issue with a missing coefficient by plugging in the 6 you need and balancing it with 1 over 6 on the outside. You are allowed to do that. Or you can fix this by saying that the dx is equal to du over 6. I hope that you started seeing this dx as a crucial part of your equation, that it's multiplied into this and you have to deal with it. So you can't just say, it's somewhere in there. So what I'm going to do is, my favorite method is to fudge the numbers. But if this makes more sense to you, go ahead. So pick one method and use it. So in integral of e to the u, and now I have du over 6, because my dx is du over 6. This is where 1 over 6 gets kicked in front of the integral, and I just have e to the u du. The integral of e to the u is e to the u, so e to the u plus c, and now I don't care about u, care about the x, which is 1 over 6 e to the 6x plus c, and there's your e to the 6x over 6, which you were memorizing in 4.9 as a formula, but now you see the full calculation in between, which gets you there, right? We do exactly the same thing with sine and cosine, which is something that I am going to ask you to work out now. So go ahead, integral of sine 3x dx. You using the same steps. I'm not going to remove this problem. I'm just going to write the problem on a board and then give you a few seconds to work on it. So integral of sine 3x dx. Use the same steps that you see on the board.
How do you get this?
There. Go. Look at it. Change the color to red. Can't see. Yeah, change the color to red.
Sign. I got you.
Do the opposite for
Yeah, it's the opposite.
Wait, integral signs, negative
Oh, yeah. That's why. Okay, that's why.
got you. I didn't even know you were struggling. Like, I got you.
No, I was gonna say something about Rib. Yeah, we just take it cosine equations, right? Plus C.
Plus C, yo, that's crazy. Almost forgot that you saved my life. Rapid fire, Dad. Good stuff. Y'all love negative 1/3 cosine 3x plus negative cosine 3x over 3 plus c. Yes. Wait. Yeah, no. Okay. No. He just added cosine. He just simplified it. Yeah. Here, I'll show you. You know what he's talking about. Yeah. No, wait. We put like over. Yeah, it's over 3, right? Yeah. That's what he did. I mean, it doesn't really matter. It's the same answer. Have you heard of Greg McDonald? Look up Ram. You're done as hell. I know what that is. I didn't know what that is. What? One. Can I get it right? Can I get it right? Yeah. Slightly different. See, I told you sometimes.
All right, let's take a look at this together. I am going to change this slightly into integral of sine ax dx to accommodate for any constant you may think of. So, again, we would say, oh, this would be so much easier if this was just sine of one variable, sine of u. And you see what u covers, right? So that's what u is. U is, in this case, ax. Du over dx is just going to be a. And then when I move dx to the other side, I get that du is equal to a dx. And now I don't have a dx, so I can fix it here. I can plug in a and 1 over a. This is another method how you can work if you don't like dividing both sides by a and stuff like that. You can just put a that you need and then balance it outside with 1 over a. So now I have 1 over a integral. Here's a peanut. If you're allergic to peanuts, just use the whole bag then. And this is the whole thing over here is du, and inside is u. So I have sine u, and the peanut is du. Here is, right, the peanut right there. A dx. So I'm replacing a dx with du, and I am replacing ax with u, and I don't have anything for sine, so just leave it there. So from this point on, I have 1 over a. Integral of sine x is negative cosine x, so this is going to be negative cosine u plus c, and then negative 1 over a cosine, I don't care about u, care about the x, so ax plus c. And this was the formula which I gave you in 4.9. I wrote this in red and I said, yeah, memorize it. Well, there it is, worked out. And now you know that u-Subtitution is responsible for creating that formula. So this becomes the 4.9 formula, which said integral of sine ax dx was negative cosine ax over a plus c. So this is the formula which you guys have seen in 4.9, and now you know where it comes from and what's going on. Cool. Next. Integral of x squared minus 9 to 31st power dx. I really don't want you multiplying these things.
That's unfortunate, huh?
I know, right? All right, so now we have a lot of stuff going on. We have a linear function x. We have a quadratic function x squared minus 9. We have this function composition with the 31st power. So a lot of things are happening at once. One of the secrets of doing well here is to look for what I call function derivative pair. Your function will always be u, and whatever is in the derivative will stay behind as a du. So, here in blood, function derivative pair. Can you find two functions that are derivatives of it? I mean, not of each other, but can you find a function with its derivative present?
Yeah.
What is it?
1 and 2x.
What do you mean 1 and 2x?
Are you saying like of this?
Yes.
What's inside?
Yes.
2x be what's inside, and then 1 be what's on the outside. Oh, to the 30th.
Can you find a function with the derivative? I think you started well, and then you start talking about these. Okay, what is the x?
Because you have the x squared and you do the derivative, you have du equals to
That one.
x.
Yes, yeah. So if you say that your function is x squared minus 9, its derivative is 2x. And you know that you can fix this 2x by 2 1/2. So there they are. Function and its derivative. Now, before you scream, well, we ignored 31. Yeah, we did. U equals a function. Du equals 2x dx. And now it's time for the peanut. There we go. That's all of that mess is your du. 1/2 integral u to the 31 du. I mean, if this is not the coolest thing you've ever seen so far in calculus, you have no emotion. Or did I say you're in the wrong field?
If you did it the other way that we were talking about, would it make it more complicated? When we're solving for like the dx over there instead in blue?
You would just have x dx equals du over 2.
Yeah,
It would be the same.
it'd be the same.
Yes.
Okay.
I'll do the next problem that way. I can sense the disturbance in the force.
Yeah. Only a little.
All right, so now we will integrate
Soon. Hopefully.
we are going to bump the exponent up to 32, and then don't care about u, care about the x, so 1 over 64 x squared minus 9 to the 32 plus c.
Do you actually want us to put it in that way, or can we put the x squared minus 9 over 64?
Whatever. What makes you happy? Come on, this is calculus. Your happiness is our primary concern. You know that.
Just don't cross the line.
Yeah, just like United Airlines. Just don't cross the line. Exactly.
Which line is that?
It's arbitrary line. It moves. We are looking for the function derivative pair so that we can set the function to be u, and then derivative will stay behind to create the du part, and then we can solve the problem. Let's take a look at, what was that? More trick? No problem. Sine to the 63rd degree of x times cosine x dx. Can we find function derivative pair in this case? What's the yeah?
You can find the do cosine and change below that the negative sign, right? So wouldn't that be your u?
Which one?
Cosine x.
Okay, you want u is equal to cosine x.
No, the way around.
Well, what? You want to take it outside now?
Let's do it.
Whichever one comes back to the classroom, right? One's coming back here, the other one's going to the hospital. All right, so this was the first call. U equals cosine x. I'm going to roll with it. See what happens. Du equals negative sine x dx. Perfect. Okay. Houston, we have a problem. Because I have 63 sines. And I only need one. And there is a cosine 1-to-1 correspondence, right?
So u is sine x?
So we're going to do the u is equal to sine x. Now, when you make a wrong choice, you will know immediately. Right? It's not bad to make a wrong choice. Guys, you are learning. It's okay to make a wrong choice. The key is to see that it's a wrong choice and fix it. So let me write the wrong choice again, just to make sure that everyone sees why this didn't work. So how many sines do I need for dx, for du? 1. I just need 1 sine for du. And how many do I have? I have 63 of them. So this problem, no bueno to solve this way. So we switch it immediately. Sine x over here, cosine x dx in here. All right, now u equals sine, that means u to the 63, and the peanut now, right there, is just going to be our du. Cosine x dx is du. What's the integral of u to the 63? Very good. And
Sine to the 64.
yes, sine to the 64 x over 64 plus c. Right? Please keep both hands on the steering wheel. I know it now looks easy, but I am in my natural habitat here, so it's gonna get very interesting. How about another sign problem? How about x to the 9 sine x to the 10 dx? What's now function derivative pair? Yes? Yes. So u equal x to the 10. The derivative du is 10 x to the 9 dx when you move it to the other side. I don't have a 10. Well, yes, you can put 10 and 1/10 on the other side, or you can divide over here both sides by 10, and you see that you can replace your x to the 9 dx with du over 10. So whatever makes you happy. We have sine u du over 10, which is 1 over 10 integral sine u du, and that's negative 1 over 10 cosine u plus c, which is negative cosine of x to the 10 divided by 10 plus c. Cass, is it good? Dividing both sides by 10? So we can either fix it by plugging in 10 and 1 over 10, like that, or we can do the divide by 10 on the right. Pick your favorite method and stick with it, right? I know both, so whatever you write on the exam, it's going to be full credit. I don't care, right? Mainly, I fix the numbers because it's faster than writing another line. But again, whatever makes you happy, do that. We haven't had any ln's. So how about ln cubed x over x dx? That's a cute problem.
feel like du has to be. I feel like du has to. See, the problem with that is that if you try to plug that in, you still have an x. So that's why now I think u has to. Well, I guess yeah, x over. It needs to be x over x. Oh no, yeah, 1 over x. No, I'm sorry. Yeah, you're right. 1 over x.
What is u?
ln x.
ln x. What's the u?
3 over
1 over x. dx.
dx.
Oh, we just did yeah, that makes a lot of sense. Oh yeah, I have to. Okay, yeah, I looked at you. That's why. Thank you.
I'm going to do this in the box here just as a side. If anyone has issues with notation in mathematics, ln cubed x means ln x everything cubed, just like your sine cubed x means sine x everything cubed. So that's just, a side notation if you have issues with that, because we are now replacing, for your fractions, you can put your ln x cubed and then times 1 over x dx, and we see the peanut right there, right? So integral u cubed du. Like, how awesome is this? You really need to be excited for these things. It's calculus. There we go. That's +4 on the final. Oh, now everyone wants to be excited. It's so easy to buy you. So we have ln to the 4 x over 4 plus c. All right. Let's cool it off a little bit. Three x to the 6 divided by x to the 7 dx. What should we do here?
Cancel it out.
Exactly.
Oh my god.
Yeah, just cancel x to the 6 and x to the 7. The answer is just 3 absolute ln absolute x, right? Plus c. So just cancel it out. Yeah, don't lose the sight of chief stuff. Can you do this by u-sub? Yeah. But there's no reason for a sledgehammer if you know, if it's just a push pin. Pretty much. Nice. I'll just cancel. Or u equal x to the 7, du equal 7x to the 6 dx. So now I need a 7 and a 1 over 7 there, which creates 3 over 7 integral du over u. Right? Which is 3 over 7 ln of u plus c, which is 3 over 7 Don't panic yet. ln of, and u is x to the 7 plus c. Yeah, 1 over 7 will go in as a 7th root and kill the 7th power. Exactly. So this is when you use a sledgehammer when you don't have to. It's okay. You okay? Did you get him? Did you get him? Okay, good. For the moment, I was concerned. Okay, what else can we figure out? Okay. Integral of 3x squared of the square root of 4x cubed minus 5 dx. Or minus 1. I hope so. Where is the problem? This problem?
Yeah.
No. It's close though.
Oh, that's not low.
Yes. It's very close. almost there. Yeah. Almost there.
Right?
What happened with this?
Oh, so
Oh, okay. Keep going. Not there
that's
yet.
right, right?
So far,
Okay.
I like it.
Does that make sense?
Oh. Not yet. But it's getting there.
I'm on my way. I'm just an idiot and I'm missing something.
Well, you're integrating u to a half. How you get u to a half again?
Because this 3 is outside. Wait, there's no wage. I'm gonna go back
U
to
to a
this.
half. Yeah. Rory, did you figure it out, Rory? Let me see.
Oh.
There we go.
Oh, I got it?
Yeah.
Get rid of it. Why is that 6?
Nope.
No.
That's not it. The function. The function. You can't have the same function again. You have the same function.
So that's cubed, right?
Yes.
Okay.
Yeah. All right, let's take a look. So, square root has this mess inside, and we are zooming on to these two because x squared is the derivative of x cubed. So, I will set u to be 4x cubed minus 5, and then du is equal to 12x squared dx. I don't have 12, so I have to fix it. So it's going to be a quarter and times 4 right there to make it 12. So now I have 1/4 integral, and I have square root of u du. Now I've seen this mistake a few times, so I'm going to write this integral out. This is a u to a half du, which is 1/4 u to the 3/2 divided by 3/2 plus c. Now, we take the fraction, we flip it up, so 3/2 becomes 2/3. The u is good old 4x cubed minus 5 to the 3/2 plus c. These cancel, and it becomes 1/6 4x cubed minus 5 to the 3/2 plus c. There it is, the full problem.
What is this? Oh.
Because math.
It's math. Yeah.
Oh, so the next problem. All right. You got it. Integral of tangent x dx.
No, I know you play.
Is there a function derivative pair here?
No.
No. Is there any kind of witchcraft we can perform so there is a pair? Sine over cosine. Nice. Get busy.
Oh, right.
GG. So what's u?
Cosine x.
Cosine x. Very good. Why cosine x?
No, because you have sin x.
Because your du has to be up there, right? It's times. dx has to be in the numerator. So the derivative of this is negative sine x dx. We don't have a negative, so we'll fix that. And I have negative integral of negative sine x dx divided by cosine x. Please don't get confused when you see this dx being in the numerator, or multiplied into like this side, because it's time dx. You can put anywhere in the fraction. So now we have negative integral du over u, and what is that? Very good. Plus c. that is negative ln, no coughing, absolute value of cosine x plus c. And now this negative sign is negative 1, which makes cosine into 1 over cosine. So ln of the cosine x to the negative 1, which is ln of 1 over cosine x plus c, which is very good. We still have trig pairing tangent with secant, right? That's never broken. So now what's a cool exam question? What's the integral of cotangent, for instance? Right? That would be a cool exam question. Do we have time for one more? Yeah, one more. Easy. Yeah, I don't want to go home early, you know. Ready? Ready. Okay. The integral of, what should we do? Sine or cosine?
Yes.
Sine? Sine. Of, well, let's put like ln x.
Sine of cosine.
dx. Now this is called mathematical flexing, when you do a problem that you don't have to do, but it works.
You sound so surprised. What are you eating, bro? What the fuck are you eating, bro? I love this part about you. Bro, I love what are you eating? No key, what are you eating? That's great. That's great.
What's you?
Negative cosine out.
Oh, that's crazy. That's what you're trying to do, bro.
Do you? In harmony, in sync. So what is this converted to?
Sine u.
The integral of sine u is
Then
negative cosine u plus c. Then what? Are we done? So what next? There it is. There will be a part 2 where we are going to learn how to deal with these when they have limits. You know, integral 1 to 3 of all of these. But we'll do that in a part 2 on Thursday. We're also going to have the review for the final, and the final is in 9 days. Your project is due in 9 days. Your labs are due in 9 days. See you next Thursday.
pray for me.